start with the first question. An achromatic combination of lens produces images in black and white, colored images, images unaffected by the variation of refractive index with wavelength highly enlarged. See, this is the answer. C. Images unaffected by the variation of refractive index with wavelength. Coming to the next question, an experiment is performed to find refractive index of a glass using a traveling microscope. In this experiment, distances are measured by a screw gauge provided on the microscope, a standard library scale, a vernier scale provided on a microscope, a meter scale provided on a microscope. So it's a vernier scale. Option C, that is a vernier scale provided on the microscope. This question, that is the distance CP is the. See, this is CP, right? So what is it they're asking? So basically your distance CP is B, that is radius of curvature. What is radius of curvature? I'll just explain you. See, this is your lens, you think, okay? Yeah. And then you have this portion of your lens. This is CP. This one is your radius of curvature. Radius of curvature. Understood? So it's option number C. Okay. Next question. The refraction of light is commonly known as, what is it known as? Okay, it is basically, I'll first tell you what is refraction. Now think there's a glass slab. Okay, this is your glass slab, and then you have a normal. Okay, now a ray of light will pass like this based on which medium it is going. If it's moving from a rarer medium to denser medium or denser medium to a rarer medium, there is bending towards or away from the region. So think there is a refraction. So there is actually a bending happening here, right? So this is your refracted ray. Refracted ray. And this one is your incident ray. Incident ray, right? This one is your normal. And again, all these are angle of incidence. This is angle of refraction, right? So what is happening here? It's basically bending. So the refraction of light is commonly known as bending. Coming to your next question, we have the focal length of the lens of refractive index mu is f. If the lens is immersed in a liquid, see, there's immersion in a liquid of a refractive index mu, then the focal length of the lens is. Basically, we know the formula 1 by f is equal to n, that is mu minus 1 minus r, 1 by r1 minus 1 by r2. What they are stating, the lens is immersed in the liquid of refractive index equal to its own. Basically, that is n is equal to 1, they say, right? So substitute this in the above equation. When you substitute, don't follow such a long method when they ask you the question. You should be really fast. This because I'm explaining it to you guys, so I'm just writing step by step. So what happens? 1 by f is equal to 1 minus 1 into 1 by r1 minus 1 by r2, right? So this 1 minus 1, 0. 0 into anything is 0. Okay, 1 by f. So f, it goes that side. 1 by 0 is equal to f. That is implies f is equal to infinity. Okay. So what is that? F, option number C. That is infinite. This is your option. Okay. But when you're solving for your ATC exam, do not write all this. Okay. Like 1 by f is equal to 1 minus 1, 1 by r1 all. You should be clever enough to see this. Okay, you're going to put 1, okay, it will deduct, and you should also not make a mistake that because this is 0, you'll tend to make this as your option. No, because there is 1 by f and they're asking you f value. So this has to come down here and this has to go there. So it's infinite. Be really careful, this type of problems, okay? Then a glass slab is placed in a path of beam, convergent light. The point of convergence of light moves towards the glass slab, moves away from the glass slab, remains at the same point, undergoes a lateral shift. Okay, so what happens? You need a glass slab. Imagine if there was no glass slab, there would be no bending or anything, right? Like this it would have come. So what? The image is formed here. Image would be formed here. Now you have a glass slab. You're going to place a glass slab. So what happens? Basically, there is a change in the image, right? Here also it undergoes refraction, here also it will undergo refraction, and then here also there is a change, here also there will be change. So image will be formed here, you think. Okay, so image will be formed here. So what is happening from this? Moves away from the glass slab. Option B is your answer. What colors of sun observed most during sunrise and sunset? That is reddish and orange. Why do you see this red and orange color? Is because basically the photons of your red and orange will be appearing for you. Okay, red and orange light least scatter. Okay, they undergo least scattering. Because of this least scattering, you observe this reddish and orange color. Okay, coming to your next question, the red light is used as danger signal because it is accepted as a symbol pleasing to eye, sensitive to eye, high wavelength. See, red light. Why do you use? What is the main characteristics of a red light? It is high in wavelength. Okay, it has high wavelength. That is, your lambda value for your red is high. Okay, and therefore it undergoes less scattering. So what happens? We can use it as a danger signal. So it's has high wavelength. This is the answer. Next, the line joining the pole and the center of the curvature of the mirror is called. What is it called? This is, what are they saying? The line joining the pole. This is your pole. This is your center of curvature. This line is called what they are asking. What is it? It's principal axis. Principal axis. Okay, this is the option. Coming to next, what happened? A convex glass lens is immersed in water. Compared to the power in the air, the power in the water will be. You should say, see, immersed in water. What is immersed? A convex glass lens is immersed in the water. We know this lens maker's formula, that is 1 by f is equal to mu or n minus 1. Based on how you've learnt denoting it, you can write the formula. Okay, 1 minus r1. What is this? This is basically your refractive index of the medium. Okay, medium in which it is going. What happens? It is going into water, right? If it's going into water, if your previous refractive index was equal to 1, now your refractive index of air, okay, this is water, you think. Refractive index of water is what? 4 by 3. You will have some decimal value which is given to you. Value is undergoing a decrease. What will happen? This will also undergo decrease. And what is power? Power is equal to 1 by f. So 1 by f value is decreasing, means power is also decreasing. Understood? So your option B is your right answer. Hope you all enjoyed the series. Keep following me. I'll teach you more regarding all these concepts so that it will clear. And as I told, keep preparing your NCERT and keep solving all the mock questions from wherever you get. It is not necessary that you will have to just follow my channel. You can start solving all of the problems or mock problems from all other channels so that you increase your speed and you know what concepts are.